Okay, perfect. Okay, so I'm so excited to have Zainab Ali here today. She is a functional programmer. We actually met at Rust Nation, I think back in March, and we were some of the few women there, and we got chatting. She's an amazing functional programmer, educator, very heavily involved in the Scala community, the London Scala user group, and has been doing lots of workshops, lots of lecturing. So I'm really excited about this. I'll hand it over to Zainab. I'm so excited that you can be here today.
Well, thank you so much. All right, so I'm here today to give you an introduction to functional programming. And functional programming is something that I really enjoy. I've been doing it for quite some time. If you want to have a look at these slides, we'll share the link in the chat, but the link is also right here, so you can go and grab them. So first of all, a little bit about me. I've been programming for maybe around 10 years or so now, but I didn't start off that way. I actually started doing a physics degree, and I started coding in my spare time. I really like designing games, and in particular designing game engines, and then went on, I suppose, quite a convoluted route, finally got a job in programming, and eventually found a few disciplines which I really enjoyed. And one of those is functional programming. Now, as I said, coding was really my hobby. So I still have that as a hobby. And I really like exploring all sorts of different languages, all sorts of different paradigms. I'm particularly interested in the smaller niche ones and the new concepts that people play around with. As well as that, these days, so I do organise the London Scala Users Group. We're a really friendly bunch, and there are lots of women there. So if you're in London and you want to meet up in person and you want to explore other languages, then why don't you come along? We have meetups regularly every month or so. Actually, I think twice a month if you count some of the workshops. And it's a really nice atmosphere. I also do a few other things in Scala as well. So I'm the Scala community representative. And what that means is that if you are working in the language and there are any challenges you encounter or little things that you see that could be improved, then I'm the person to talk to. And I'll feed all of that feedback on and hopefully get those things resolved. As well as that, I do code as my day job. But I also really enjoy teaching. And I really enjoy, in particular, trying to understand the way that people think about code and think about solving problems. And that's one of the reasons why functional programming in particular is such an interesting discipline. So why functional programming? And also, I'm sure, what is functional programming, right? If you go and look online and try and understand what functional programming is, you'll find probably quite a few tutorials in lots of different languages, but they all tend to be quite abstract. And that is because functional programming itself is quite an abstract thing. The way to think of it is that it is a technique. Just as you have many other techniques for trying to achieve good code, let's say you start off writing spaghetti code and you want to improve it, you might decide to name things differently. You might decide to structure it differently. You might decide to write tests for it. Functional programming is another technique that you can apply to the way that you design your programs that will help you reason about them. Now, as I said, that's rather abstract, but don't worry. What we are going to do is go through things quite slowly, and we're going to go through things in concretes. What we're going to do is start by taking a look at a nice concrete problem and design a very basic app. It's going to be a birthday app. There will be some bugs in this. So what we're going to do is that we're going to go and hunt for those bugs. And when we find them, we'll rewrite our application and use some functional programming techniques. Okay, so I said, let's start with the concrete app. So this is it. I've written a program. It is a Rust program, and it's called Birthday. And what it does is that it prints out a message which congratulates us on our birthday. For instance, let's say that I was born in the 2000s, and I was born, well, today, right, on the 6th of August, and I fed this information into the birthday program. It would print happy birthday, and it would congratulate me on becoming 24, which is how old I would be. If, on the other hand, my birthday is in a couple of days, let's say it's on Thursday, what this program would print is that it's not my birthday yet, and it would tell me to wait. And let's say that my birthday is already past this year. Let's say it was yesterday. Then what I want this program to do is print that I've already had my birthday and tell me that I hope I had fun. I hope I did. All right. So now the code for this is quite simple. This is not functional code, but this is how I might write it. So there were 3 different things we wanted it to print, right? If our birthday was today, we wanted to print happy birthday, and we wanted it to print our age. If, on the other hand, our birthday was past, let's say our birthday was yesterday, we want it to print we've already had our birthday. And finally, if it's not our birthday yet, we want to print the number of days that we need to wait until our birthday. So hopefully that's all good so far, right? This code, it reads quite well, doesn't it? I've said it's not functional code, but at least it's easy to read through. It's easy to understand what we're trying to do here. But I did say that there were some bugs, right? So one of the rules that I want this program to obey, if it is not my birthday yet, then that means that it's my birthday tomorrow or the day after or sometime after that. That means that I should wait for at least 1 day, right? So that number of days that I wait for should at least be 1. But I actually tried to test this yesterday, was up late at night making sure that this program was correct. And it was around midnight, and I ran it. I ran it midnight yesterday with the day today. And it said that it wasn't my birthday yet, which was true. But it told me to wait for 0 days. And that shouldn't happen. So the thing is that if we look at this code, we try to understand why that's the case, it becomes very difficult for us to actually reason about. Okay, so what do we mean by reason? So if I were to look at this code, I would know, for instance, that we at least got to this line, right? Because we printed that it wasn't our birthday. But our days until birthday was 0. Now, the fact that we know that we got to this line means that our birthday must have been greater than today, right? And so we expected this number to be 0. So this is some kind of flaw in our reasoning about the code, right? We're trying to reason about it, but we're finding that we can't. Something is happening that we don't expect. So to actually find out what that is, we need to go and look into these functions, right? Look into what birthday is doing, what today is doing, and what days until birthday is doing. So let's have a look. So the function today, it gets us the current date, right? It calls UTC now, so says, okay, what is now, and gets us the current date. The function birthday calls this other function called date of birth, and it does some sketchy stuff. It unwraps. Let's ignore that for now. And what date of birth does is that it gets the argument that we pass in, and it tries to convert that into a date. So what we do for birthday, right, is that we take the date of birth, which we get from the input. We set the year to be whatever year it was today, and thus we get our birthday. Okay, so I can have a look at that that code now, and I can try and figure out where the bug is. And I encourage you, if you're watching this afterwards, by the way, spend a bit of time here, see if you can spot it yourself. I'm just going to tell you for the moment. And that is that the values that we return here are values that can change. In particular, if it's close to midnight, the value before midnight for today is the current day, and the value afterwards is now different. It's a day ahead. So what that means, if we take a look at our main function, is that today, when we first called it, may have been the 5th of August, right? But then when we actually called it later, we called it in days until birthday as well, it was the 6th of August. And so what we actually got was a condition here, which we hit, in which we thought that it wasn't our birthday, but in fact, as the function was running, it became our birthday. And our days until birthday ended up being 1. Oh, sorry, ended up being 0. Okay, so that's a bug. And we're going to see how we can resolve this bug. But as we resolve it, we're also going to see how we can apply some functional programming techniques to ensure that we wouldn't have had the bug in the first place. So as I said, functional programming, it's a technique that we can use along with things like tests, along with naming and structure, to make sure that our code is easy to understand, reason about, and essentially bug-free. And the first thing that we're going to look at is how to write pure functions. So a pure function is, or a pure expression, right, is something that can be substituted with its result. Now let's think back to your early days in maths, right? You were presented with something like 1 + 2, and you were asked by your teacher, okay, what does this evaluate to? And we can still all do numeracy even though we use calculators, right? 1 + 2 is 3. So I know that if I see an expression, right, that x is 1 + 2, I can mentally substitute that with 3. And I can do the same with other expressions, right? It doesn't need to be numbers, right? Let's say that I have an option, which is a sum of 5, and I ask, is this empty? Right, now the expression, sum 5 is empty, is basically equivalent to false. I can mentally substitute that. I can also mentally do the reverse, right? I can expand whatever this isEmpty function is doing into a pattern match. So a pure function can be substituted for its result, and its result can also be substituted for that function call. However, we also have a lot of functions which aren't pure, right? A lot of expressions which aren't pure. For instance, let's say that I'm printing happy birthday. The result of printing happy birthday is unit, but clearly printing happy birthday is not equivalent to unit, right? It's doing some other stuff. It's doing what we call a side effect. So that's something that we don't see in the result. Now also, if I call this function today, that's not equivalent to just defining what its result might be today, because if I were to call it tomorrow, it would give me a different thing. You can kind of say the same for our argument list as well, right? When we get our arguments, they aren't equivalent to just a vector of what those arguments are. Because if we were to run this program with a different set of environment variables, sorry, a different argument list, we'd get something else. So that means that it is a little bit more difficult to reason about these functions, right? It's a little bit more difficult to reason about what the result of today is or what the result of getting our arguments is. Now, we always need to have these functions which have side effects, but not all our functions need to do that. So I'm going to rewrite the code that we had. It's going to look slightly different now. What we're going to do is that we are going to get the date today at the very beginning, and we are going to store that in a value today. So that's here. And what we're going to do now in our later code is just refer to this value. Similarly, we can do that for our argument input. what we're going to do is get the argument out of our argument list, and then in our later code, just refer to that value. What that means is that we can write some more functions. We can write a function, for instance, that calculates the date of birth from our input. And this function itself is pure. It is pure because for a given input, I can substitute calc.dob of that input with its result. So I know, right, that the date of birth isn't going to change. And I know that the birthday here, this value, isn't going to change because the function calc birthday is pure. Just to help us understand the code in these examples, I've tried to make all the pure functions prefixed by calc. Not that you should do that in your actual code, just to simplify these ones. So what that means is that, let's say that we decide to calculate the days until our birthday, and we decide to calculate those days as a pure function. We know that the value that we pass in to today is going to be the same as the value that we used when trying to evaluate this if statement. So in doing this, we have actually solved our bug. I can now read through this code, and I can be absolutely sure that by the time I get to this branch, today is always going to be less than the birthday because I've done this if statement here. So I can be sure by the time I've got to this branch that this number is never going to be 0. Okay, so a quick recap on pure functions. Pure functions are functions which don't have side effects. We've written a few of those, such as calc date of birth, calc days until birthday, and calc birthday. And we haven't shown you the definitions of those, but you can be sure that they're pure. And we also have a few functions with side effects, such as getArg and getToday, and we executed those at the very beginning. So we kind of sectioned off our side effecting code from our code that wasn't side effecting. The really nice thing about that is that we can test it. So over here, we have a little test that actually tests our days until birthday function. Because it is a pure function, we can be reassured that we can substitute whatever it evaluates to with its result. And we can do that, we can be assured that that will behave the same in our tests as also in our production code. So I can write a test now for this case in which we had the bug, right? Today was the 5th, right? And our birthday was on, 26th, but let's say that was the 6th. If we calculate the days until our birthday, we would end up with 1. However, not all of our code is actually testable. We do have this block here in which we are printing. And wouldn't it be great to be able to test the output of this if statement? We can't do that because println is side effecting, right? The actual main thing that this does is that it prints a message, and that's not something that we can actually observe in just the result. But what we can do is that we can decide, instead of printing straight away, why don't we create another function and model the kinds of things that we want to print. So what we can do is that we can model our 3 cases as an enum. Our 3 cases, that it's either our birthday, we print happy birthday, or we've had our birthday and we print that, or we want to wait for a certain number of days. And we can model this as an enum in Rust. And we can then write a pure function which will calculate this enum, this message. Once we do that, we can decide to then take this message and then execute the side effect separately. So here's what this calc message function might look like. It basically does the logic that we previously had in our main, but instead of printing, what it does is return a message. Now, the great thing about that is that we can take it and print it. We can just pattern match on this message and print what we want. And we can also segregate it from the rest of our code. So now if we have a look at our main function, we see that we have our side effects first, right? We get whatever today's date is. We get the input straight away. We calculate our message, and the calculation is completely pure. And then we have a side effect at the end for printing. Oh, and the great thing about this, by the way, is that now calc message is much, much easier to test, right? We can now test that we, let's say, had our birthday in the past, that we actually get a had birthday message at the end. So here's a quick recap. We've had a look at pure functions. So we've seen that a pure function is one that just evaluates to its result and doesn't have any side effects. We've also had a look at side effects. And we've also had a look at how to model data. If we were to run this program, though, we would see that there would be a few more problems. And you may have noticed that we had some unwrap calls, and we panic as a result. In fact, we panic in 3 cases. If we were born on a nonsensical date, or in the future, or some arbitrary string, we'll panic. And that's not necessarily a good thing. So with functional code as well, what you really want to have in your result is an output for all of your possible inputs, including the ones in our code which would make us panic. Instead of panicking, ideally what we would do is return some kind of result. And the great thing about Rust is that it actually has that result type. So what we can do is that we can decide to enumerate all of our errors. We said that there were 3. And we can change our function signature for calc message and calc date of birth to actually return a result which may encompass this error. So by doing this, what we're saying is that these 2 functions, calc message and calc date of birth, they may fail with a result, but they will not panic. And so they are defined over all of their inputs. And Rust has also some really nice syntax for handling those results. You might have seen the question mark operator. That's a great way to chain your results together. And the great thing about that is that we can write tests even for our error cases, right? So let's say that I actually put a date in which is in the future, right? I say that my birthday is long ahead. Then I will get an error as a result, and I can test that. Okay, so we've learned some basic principles of functional programming, and we've learned the ones that will help us reason. We've learned how to write pure functions, how to identify side effects, to model data, and also to write total functions, so functions that are defined over all of their inputs. And the result of that is largely bug-free testable code. Now, it doesn't read quite the same way. However, it is much easier to reason about. Now, there are all sorts of different approaches and opinions, right, on what good code is. And there isn't really one solution, right? People have had this debate for years. There are lots and lots of different ways that you can write code. But I do think that in writing code that helps you reason, you are on the path to writing something that's a little bit better. So functional programming is a technique that you can kind of combine with a lot of other different ones in order to improve the quality of your code. All right, well, I hope you enjoyed that. And if you'd like to find me later on, I am on LinkedIn. I'm also on GitHub, and I have a newsletter, which hopefully you'll see more posts on. And you can also email me as well. If you ever go to Rust conferences, I will be at Rust Lab as well. I'm giving a talk on reasoning with async Rust, which will be somewhat more advanced, and we'll have a look at concurrency features.
Brilliant. Thank you so much. That was amazing. A real like a very comprehensive introduction to functional programming. When I think of functional programming, I often think of coming from a background of more stats, so statistical programming, which is very functional. So this is really interesting to see how it can be applied in Rust. I think we're going to switch to some questions now. So we've got the Q&A feature, which is at the bottom right-hand side of the screen with like a triangle, square, and circle. So if anyone's got any questions, just put them in there, and it'd be great to sort of hear what everyone has to say. I wrote down a couple of questions, which was so what features of Rust do you think makes it particularly good for functional programming? It sounds like you really like the error aspect of it, and being able to define your own error and change the signature, but is there anything else, or do you want to expand on that?
Yeah, there are a few. So well, I should say that there are different levels of functional programming, right? So the things that I've presented here are really how you can get started and apply these core concepts into your code. And so I think the things that Rust has are things like data types like result, also option, the lack of an error channel, right? So the fact that you either panic or you return a result is actually quite a good thing, I think. It means that if you write a library, you're a lot less likely to panic. And so it's a lot easier for you to reason about your code. I'd also say that, now one thing we haven't touched on, right, is Rust's approach to modeling mutability, making sure that actually things are not mutable by default, right? Everything, if you define it, it's not going to change, is something that's very, very useful.
Great. And just, did you make much use of traits? Because I think we all have different styles. I use errors. I really like having custom errors. I think it's a really powerful part of any programming language, but particularly Rust. But I think of it more as like, I guess, like a trait in some way, rather than, or making use of the trait system. I guess it's technically not, but anyway, it's just a different approach. Do you make use of traits?
Yeah, now that's a different aspect, which we haven't really discussed, is how you, I suppose, decide to dispatch things. So to explain what that means, a lot of the time you have a piece of code and you actually want different behavior in that code, right, depending on what inputs you pass in. So traits are a good feature to try and help you do that dispatch, so help you achieve different behavior for different inputs. I'm really interested to see what you mean by traits and errors. I wonder if let's see, is there any code that we can refer to which will help help explain what that is?
So I guess maybe I sort of didn't explain it well enough, or maybe I've got the wrong end of the stick. I guess so a lot of the code that I've written recently, we have like a custom error. So say like, I guess where error would be, instead of that, it might be a custom error. So something that we have overwritten. It's not a trait really, it's a strut. But one of the things which is nice about it is in testing, you can sort of apply, if you're thinking about it in terms of like traits, you can then apply traits to different kind of types of objects or type of struts, including tests, like a testing strut. I don't know, it's kind of hard to explain, but it's something which we've been, I guess, experimenting with, and I'll let you know how well that goes.
Cool. Yeah, maybe if we could have a look afterwards with some code snippets. What I can do with all of this is pop them in a repo, and then maybe we can add some more as well.
Yeah, that'd be great. That'd be great. So there is a question from Giza. So to what degree do you use functional patterns in projects at work? And then follow-on question, is it an easy sell to teammates usually?
Okay, well, I'm a bit spoiled because at the moment I do work in Scala, and functional programming is a very easy sell, and we always use it. But I think as for how easy it is, there are a couple of factors there. One is that it really lends itself to some domains. It lends itself in particular if you're writing, for instance, quite a simple business application. And you have something like this application where you can quite easily segregate out the side effects, right? Now, in general, if I'm training a team and they're not doing any functional programming yet, I'm not going to go full on and say, okay, well, you have to use this absolutely functional stack, right? You kind of introduce it slowly. And I find that as people start reasoning in this way, it becomes much easier to sell. Because the initial gains, right, they're quite obvious, right? You can write much more testable code. And interestingly enough, I actually think that it depends on the domain. So functional programming works very well kind of in the large, in those sorts of business applications. But in the small, when you have an algorithm, for instance, a lot of the time you can write an algorithm in a way that is mutable, so not functional, and is also more optimal. So I think the areas in which it would be quite a hard sell is if you, let's say you already have an algorithm which you've written in Rust, which does some statistical calculation, let's say, but does it in a way that requires a lot of mutation for performance. That's actually quite a hard problem to apply functional programming to. And not necessarily, it's not always the best approach, right? Because yes, you end up with code that's easier to reason about, but you also want to make sure that it is performant. So yeah, so I suppose I find it easier when you have these more large-scale business problems to apply these patterns. And in general, applying these patterns is you can do it gradually, right? You can start by enumerating your errors, for instance, and start by using result, and that's quite easy to do.
Brilliant, thank you. I really appreciate the fact that you've given me the language to use, so the side effects and the pure function. I've been aware of this. I've told many people, not to return, especially in Python, not to print things within functions. But I didn't have the language of, that's a side effect. So I think that's really useful. It's one of the things I'm going to take from this for sure. Are there any other questions? And then I think if we don't have any more questions, we'll turn off the recording and then we can have more of an open discussion. We'll just double check the questions again. All right. Okay, I'm going to turn off the recording. Just before we go, thank you very much again for this talk, and it's been great. Really appreciate it.